For over a century, the laws of physics have presented us with a deeply unsettling mystery. When we look at the equations that govern the universe, the laws of motion, electromagnetism, and general relativity, they appear to be perfectly time-symmetric. This means that if you were to film a subatomic particle moving and then play the video backward, the physics would still look correct. The equations don't care if time flows forward or backward. Yet in our daily lives, time is a one-way street. We remember the past, but not the future. Eggs break, but never unbreak. And we all inevitably grow older. This arrow of time is one of the greatest paradoxes in science. To resolve it, some of the world's leading physicists have proposed a radical idea that at the moment of the Big Bang, not one, but two universes were created. One is the universe we inhabit, and the other is a mirror universe where, from our perspective, time runs backward. This concept isn't just a plot for a science fiction movie. It is rooted in a fundamental principle of physics called CPT symmetry. This principle states that the laws of nature remain the same if you flip three things at once. The charge C of all particles from positive to negative, the parity P or mirror image of their spatial coordinates, and the time T they experience. For decades, physicists have assumed that the universe as a whole must obey this symmetry. However, our observable universe appears to violate it. We see a world made almost entirely of normal matter rather than antimatter, and we see time moving in only one direction. To balance the cosmic ledger and preserve CPT symmetry, researchers like Dr. Latham Boyle and his colleagues at the Perimeter Institute have suggested that the Big Bang was a symmetry point. On one side of this point is our universe, and on the other is its CPT symmetric twin mirror image made of antimatter and flowing in the opposite temporal direction. To visualize this, imagine the Big Bang not as the beginning of time, but as a Janus point named after the two-faced Roman god of beginnings and transitions. If you stand at this point, you see two futures stretching out in opposite directions. For the inhabitants of that other universe, their time feels just as forward as ours does to us. They would see their stars forming, their galaxies rotating, and perhaps their own civilizations rising. But if we could look across the Janus point into their realm, we would see a world where the effects precede the causes. It is a concept that challenges our very definition of reality, suggesting that the beginning of time was actually a middle, and that our universe is only half of a much larger, perfectly balanced whole. This theory offers an elegant solution to one of the biggest headaches in cosmology: dark matter. In our current model, we have to invent a mysterious, invisible substance to explain why galaxies don't fly apart. But in the mirror universe model, dark matter might not be a thing at all, but a natural result of the symmetry. The theory predicts the existence of a specific type of right-handed neutrino, a particle so elusive that we have never detected it. In a CPT symmetric twin universe, these neutrinos would be produced in exactly the right quantities to account for the gravitational effects we attribute to dark matter. If this is true, we don't need to look for dark particles in our own sky. We are simply feeling the gravitational ghost of the particles in our mirror twin. But how could time actually run backward? To understand this, we have to look at entropy, the measure of disorder in a system. The second law of thermodynamics states that entropy always increases over time. This is why things fall apart and heat dissipates. Many physicists believe that the arrow of time is simply the direction in which entropy increases. In the Janus point model, the Big Bang was the state of the lowest possible entropy, the ultimate point of order. As the two universes expanded away from that point, entropy began to increase in both directions. Therefore, the future is simply the direction of increasing chaos. From the perspective of the mirror universe, we are the ones living in the past, and our time is the one running backward. This leads to a fascinating philosophical question. If there is a mirror universe, are there mirror versions of us living there? Most physicists argue that the answer is likely no. While the laws of the mirror universe are symmetric, the events are not. Think of it like a deck of cards. Even if you have two identical decks, the laws of physics, and you shuffle them according to the same rules, the symmetry, the specific order of the cards in each deck, the history of stars, planets, and people will be completely different. The mirror universe would likely have its own galaxies and stars, but they would be arranged in different patterns. It is a twin in essence, but not a duplicate in detail. The search for evidence of this mirror universe is currently underway. One of the smoking guns would be the detection of primordial gravitational waves with a very specific polarization. When the universe was born, it should have sent out ripples in the fabric of space-time. If the mirror universe theory is correct, these ripples should bear a signature of the CPT symmetry. New observatories like the BICEP array in Antarctica and the LIGHT BIRD satellite are looking for these subtle twists in the cosmic microwave background. If they find them, it would be the first direct evidence that our universe has a partner on the other side of the Big Bang. Another clue might come from the study of antimatter. In our universe, antimatter is incredibly rare, even though the Big Bang should have produced equal amounts of matter and antimatter. This is known as the baryon asymmetry problem. In the mirror universe model, this problem disappears. All the missing antimatter isn't missing at all, it simply went the other way. The mirror universe is an antimatter universe. If we could ever find a way to communicate with that other side, we would have to be extremely careful. Any physical contact between a person from our side and a person from the other would result in the most powerful explosion possible, as the matter and antimatter annihilated each other instantly. The implications for our understanding of the Big Bang are profound. Usually, we think of the Big Bang as a singularity, a point where the density was infinite and the laws of physics broke down. It is a mathematical wall that we cannot see past. But the Janus point model suggests that the Big Bang was finite and transparent. It wasn't a wall, but a window. It means that the universe didn't emerge from nothingness. It expanded out of a state of perfect balance. This removes the need for inflation, the theory that the universe expanded faster than light in its first fraction of a second, which many physicists find problematic. Instead, the symmetry itself provides the stability and uniformity we see in the sky today. However, the theory is not without its critics. Some argue that it is unfalsifiable, that because we can never travel to the other side of the Big Bang, we can never truly know if the mirror universe exists. Others point out that quantum mechanics might forbid such a perfect symmetry at the moment of creation. There is also the Boltzmann brane problem. If the universe is perfectly symmetric and infinite, then the laws of probability suggest that random fluctuations could create fake memories or even entire observers out of the void, making our observations of the real world unreliable. Despite these challenges, the allure of the mirror universe remains. It appeals to a deep-seated belief that many scientists hold, that the universe is, at its heart, beautiful and balanced. For centuries, we have discovered that nature loves symmetry. We see it in the shapes of snow crystals, the orbits of planets, and the structure of atoms. It seems only natural that this symmetry should extend to the very largest scales of time and space. The idea that we are part of a cosmic binary makes the universe feel more complete, less like a random accident and more like a carefully orchestrated masterpiece. As we move into 2026, we are entering a new golden age of cosmology. We are building telescopes that can see further back in time than ever before, and detectors that can feel the tiniest vibrations in gravity. We are finally probing the edge of the Big Bang. If the mirror universe is there, we are closer than ever to finding its signature. We might find that the beginning of time was actually a gateway, and that our story is inextricably linked to a twin world that we can never touch, but whose presence we can feel in the very rotation of our galaxies. Living with the knowledge that there might be a mirror universe where time runs backward changes how we think about our own lives. It suggests that time is not just a fading light, but a fundamental dimension that stretches in both directions. It makes our now feel more significant, a unique point of awareness in a vast, symmetric continuum. It reminds us that for every action we take in our forward time, there is a cosmic balance being struck elsewhere. We are travelers on one half of a great bridge, and while we can only see the path in front of us, the bridge itself is whole. The mirror universe might eventually turn out to be the most important discovery in human history, or it might remain a beautiful mathematical dream. But either way, it forces us to expand our imagination. It pushes us to look past the obvious flow of time and see the deeper, hidden structures of reality. It reminds us that the universe is under no obligation to make sense to our primitive, three-dimensional brains. There is a grander logic at work, a music of the spheres that plays across the Janus point, connecting the matter of our world with the antimatter of the other. As you look up at the stars tonight, imagine for a moment that you are looking at a reflection. Imagine that for every star you see, there is a mirror star moving in the opposite direction of time on the other side of the cosmic horizon. We are part of a grand, temporal, dance, a universe and its shadow, a cause and its effect, a beginning and an end that are one and the same. The mystery of the blue sunsets on Mars or the rings of Saturn are wonders of our local neighborhood, but the mirror universe is a wonder of existence itself. It is the ultimate expression of the cosmic connection, a reminder that in the grand design of the vacuum, nothing is ever truly alone. Whether we are forward or backward matter or antimatter, we are all part of the same ancient light. The Big Bang was not just the birth of our world. It was the moment the universe decided to see itself from two different perspectives. We are the explorers of one side, and perhaps somewhere across the Janus point, another version of curiosity is looking back at us, wondering if we are there. In the silence of the night, the mirror universe whispers to us that the story is much bigger than we thought. The arrow of time may point one way for us, but the bow is held by a symmetry that spans the infinity of the void.